Okay, so we got your review and everything. So we're just going to start going through it. It'll be just like the review that we did in class. Okay, so the first thing is we want to take 321 centimeters and change it into kilometers. So remember in class we talked about the metric system because that's what we're dealing with. And the metric system starts with km, then hm, then DAM, meters, decimeters, centimeters, and I ran out of room. So let's grab this stuff, slide it over. Slide it over a little bit. All right. Come back here. Okay, yeah. Draw on it, erase. Just want to move these guys out to the side a little bit more. DM, CM, MM. Okay. So when we are moving and changing from one measure to another, if we start large and move to the right, we multiply. Good. You got it. So when you move to the right, we'll multiply by 10. We move to the left, we divide by 10. Okay. So, say it again. There we go. So, yeah. So what John said is that we're starting down here at centimeters, and we're moving to the left 5 times. So if we're thinking along the lines of dimensional analysis, that's 321 centimeters. And what we're going to multiply it by is 1 kilometer over 10 being multiplied 5 times. Because that's how many centimeters it's going to take us. And then in the end, we end up with what number? Not 100,000. You got to make sure that you, yeah. On the bottom, we get 100. Well, it's not 100,000 on the bottom. It should be 10,000. If you multiply all this guy out, you should be at 10. No, sorry, you were right. 100,000. Joking. Come on, draw tool. Just fix that right there real quick. So you end up with 100,000 on the bottom. So what is 321 times 1 over 100,000? 1 over 100,000. 0.0031. You got it. So 0.00321. And remember, everything in this test takes labels. So don't forget those labels. So it's kilometers. Perfect. Now also remember that in class I taught you another way of doing this. Since we're moving to the left 5 times, that's just like taking this number right here. Here's my decimal, and moving it to the left 5 times. 1, 2, 3, 4, 5. So this is where the new decimal goes, and then all my zeros tack on in there. 0, 0. So 2 ways to think about it. This way that we did first, that was dimensional analysis, and then this is just moving your decimal because that's what happens when you multiply and divide by 10. You move the decimal. All right? Let's jump to number 2. So the cool thing is, if you're going to do anything on this test as far as conversions, other than if it's metric, you need to know that information. But if it's other than metric, I'm going to give you the relationship that you need to work with. So you don't have to memorize all those different conversions. That's just crazy. So this problem says, given 1 inch equals 2.54 centimeters, use dimensional analysis to change 100 inches to centimeters. So we want to go from 100 inches to centimeters. So what are we going to multiply by?
We're going to multiply by 254.
2.54 centimeters on top over what?
1 inch.
1 inch. Good. Because the label we're trying to get rid of goes in the denominator. The label we want goes in the numerator. So when we multiply all that, what do we get?
Wait a minute.
No worries.
So it's 254.
Yeah. 254. Nope. It is 254. Okay? All right. And that's pretty much what questions 1 through 14 are going to be like. It's just all this dimensional analysis or converting. So here it says, if you jog 3 times around a track that is 500 meters long, how many kilometers have you covered? So what do you think we're going to do first on this, John? What do we got to know?
Well, we got to know how many kilometers we covered.
Okay, so in the end, that's what we want. In the end, we want to know how many kilometers we went. But before that, what do we got to know? It's okay. No worries. The first thing that you got to figure out is how far you actually jogged, right?
We jogged 3 times around the track.
3 times around a track that is how long? How long is that track?
3 times.
No. That's how many times we jogged around it. But how long is it?
500 meters.
500 meters. Your first step is to figure out your total distance. How far did we actually jog? 3 times this number. What is that? So we actually went 1,500 what? Meters. So that's the first thing you got to do, is you need to find out how far you jogged. And that's what we did right there. We took the 3 times the 500. Erase this bar, rewrite that. Does that make sense? Okay? And so now we can take this and convert it to kilometers. So this goes, again, right back to what we just started out with in that metric system. Kilometers, and then your HM, your DAM, your M, and then blah, blah, blah. We only need that part of it. So what are we doing here? Are we moving to the right or are we moving to the left? Yeah, to the left, because we're going to divide. That's right. There you go. So we're going to take 1,500 meters. We're going to multiply it by 1 kilometer is exactly what you said. multiply 10 3 times. Which is 1,000. There we go. So we take the 1,500 and multiply that by the 1 over 1,000, which gives us the 1.5 kilometers. Or again, you can move the decimal. So remember again how we talked about the decimal. We've got this number right here. That's my decimal, and we got to move it 3 times. 1, 2, 3. No more comma. So that's 1.5. Either one is good. Either one is good. Feel okay on that one?
Well, I understood the first part, but to find the kilometers, it got me a little bit.
It's just like what you did on number 1. So remember how up on number 1 we just had to move? Because we're still in the metric system. This is metric. This is metric. So that's just you're moving of either multiplying by 10 or dividing by the 10. Okay? Because remember, once you knew how far you went, you're still in meters. But in the end, we wanted kilometers. Yeah. Okay. All right. Numero 4. So notice again, right up here, I give you the conversion to work with. Okay? So we want to express kilometers per hour in miles per hour. Okay? So we have 70 kilometers per hour. And we want to express this in miles per hour. You follow me on that? So really, who are we changing?
Well, we're changing the kilometers.
Yeah, we just want to change the kilometers. Don't worry about the hours. The hours doesn't do anything. Don't worry about those. Just use your conversion that you have right here and change kilometers to miles. So what are we going to multiply by? What over what? Is where? No, 1.6 is not above.
We'll multiply my miles and divide it by 1.6.
Yeah, remember, the label you're trying to get rid of goes in the bottom. Kilometers. Yeah. And then on top should be the 1 mile. So when you go through and you do your multiplication, all we're going to do is take 70 times 1 over 1.6. $43.75 miles per hour. There you go. That's the answer. Feel good on that?
Just to be clear.
Sure.
Well, if I'm dealing with this question in the test, so what I have to do is multiply actually. Well, the hour just stays the same?
Hour just stays the same. Hours along for the ride. Because what happens when you take out the kilometers, that label is now gone at the bottom, right? So it's still left with hours.
Miles per hour.
The hours just transfers along. Because we canceled out the kilometer. And that left the miles, miles on top. Good. All right, number 5. So a simple question. We want to put one of these 3 symbols in that blank, or one of those four symbols. So remember when I talked about this in class, when you're thinking like millimeters, think like the size of a pill. Okay? When we're thinking kilometers, think like miles. When you're thinking a meter, think of like a yard on a on a football field. And then centimeters, kind of think like inches, kind of inches. So, but actually a centimeter is smaller than an inch, just so you know. But because it's about 10 centimeters and 1 inch, about. So, the human heart is 20 blank wide. So which symbol do you think we should put in there?
20
Meters? That would be a huge heart. Because meters is like yards. You're saying that it is 20 yards long. I mean, that would be like a giant heart sitting between the goal of a football field and the 20-yard line. That's one huge heart. Ain't going to be that one. And which also makes us believe that it's not going to be kilometers. A 20-mile heart? What kind of animal would have a 20-mile heart? Or a human? Yeah. Centimeters is definitely right. Because millimeters, that's just way, way too small. Way, way too small. So definitely, centimeters. That's it. Okay. That's all you do on that one. Just tell me which label you would use. All right. The next one, it says, given 1 acre, which is about 0.4 hectare, use dimensional analysis to find the area of a property measured at 20 hectares. Now, I know in the past many students get confused by this word area. You basically want to find the acres. Oops. The acres. Don't let the word area throw you off. It really just means convert this to acres, which acres is a form of area. So how are we going to do this? We know we got 20 hectares. We want to convert it to acres. Yeah. What are we going to do? What are we going to multiply by?
Well, 1 acre and then divide it by 0.4.
Okay. 1 acre on top. I like that because acres is what we want, and we're getting rid of the hectares. So I like that you said put the hectares in the denominator. It's a horrible E, but close enough. So you're going to take 20 times 1 over 0.4. 50 acres. Perfect. There you go. Easy peasy. All right. Number 7. Notice down here I give you 2 conversions. What's that going to tell you? If I give you 2 conversions, what am I giving you a big hint about what you're going to do?
Millimeters and
There's no millimeters up here. The L stands for liters, milliliters.
we're gonna convert it to tablespoons in 24 hours.
Okay. Yes, we want to convert the 6 tablespoons. And who do we want to convert that to? Well, not in hours. We have 24 hours. But what label do we want in the end? There you go. It's called fluid ounces. Whoops. Untitled page? That's no fun. We'll just pretend that never, yeah, it's a good idea. And it keeps adding me an untitled page. That was my fault. Go back up here. All right. So, we'll just slide it over. That's better. All right. But because I give you two conversions, do you think that we're going to have to use both of them? Yes. Yeah, that's what I was trying to get at earlier. If I give you two conversions, there's a reason for that, because I want you to use both. Because we don't have a relationship between tablespoons and fluid ounces. We don't have a direct relationship. But we do have relationships that we can go from tablespoons to milliliters. And then there's a relationship from milliliters to fluid ounces. Does that make sense? So it's like we're going to jump to different measurements to get us where we need to be. It's like, think about it like a kind of like a flight. If we are traveling to, I don't know, say California from Florida, okay, most likely you probably have what is called a layover, right? Somewhere. That's what this is. We don't have a direct flight from tablespoons to fluid ounces. We have to go through a layover. A layover would be like milliliters for us. We can convert tablespoons to milliliters. And then from milliliters, we can fly the rest of the way to fluid ounces. Does that make sense a little bit now? Yeah. So let's start setting up our dimensional analysis. We're going to have two fractions that we're working with. So how do I get rid of tablespoons? What are we going to use here? What is this piece going to look like? Whoa, come back here. What will our fraction look like here? We want to get rid of tablespoons and start moving to where we need to go. No, tablespoons won't go above. Remember, we want to get rid of tablespoons below. So 1 tablespoon below. And what do we know about a relationship? Who is it related to? Milliliters above. And what is that number with the milliliter? All right. Now, no, fluid ounces will not go below. It has to go above because that's what we want. The guy you want goes above. The one we want to get rid of goes below. So 1 fluid ounce is up here. And what's below? The 30 milliliters. Because we got to cancel this guy out, the milliliters. So this is what you're going to multiply everybody by. You're going to take 6 times 15 times 1/30.
Three fluid ounces.
There you go. So in 24 hours, do not exceed 3 fluid ounces of this medicine. Okay. All right, number 8. Number 8 says a swimming pool has a volume of 150,000 gallons. Given that 1 cubic feet has a capacity of 7.48 gallons, how many gallons of water does the pool hold? So, that's a little weird. I messed this question up when I wrote it down. We're already in gallons, right? So technically we already have the answer. So let's just fix this. Let's cross out the word gallons and let's ask how many cubic feet it holds. Oh, I wrote foot, should be feet. Because technically we're done with this question if I asked about gallons. We already know that. My bad. So we want to know how many cubic feet does the pool hold. So we're in gallons right now, right? In the end, I want to be in feet cubed. So do we know a relationship about gallons and feet? Yeah, it's right up here. Even though I didn't write it out with an equal sign, this part right there tells you about the relationship between gallons and cubic feet. So we want to get rid of gallons. So where does that go? Below. So we're going to have 7.48 gallons. And 1 cubic foot goes on top. There you go. So all we need to do is take 150,000 times 1 over 7.48. And that will tell us how many cubic feet we have. I have to go back and fix it.
253.475.
So kind of a long decimal, right? So we'll just round this to the nearest hundredth. So 20,000, how much?
253. Sorry, 20,053.
53. And then to the nearest hundredth, which will be 2 decimal places, is what? Point what? Nearest hundredth. Now you got to look at your calculator. So 2 decimal places.
200?
No, not 200.
200.53.
Well, that's what we've got. 20,053. Don't move the decimal. I want you to round. I want to know what are these 2 decimal places that are right here. Nearest hundredth means I want 2 decimals. So point what?
47.
But what's the number after the 7?
5.
What does the 5 tell the 7 to do? So it's point what? 4, 8. There you go. Okay? So 20,053.48 cubic feet. Okay. Number 9. If it wants to move to number 9, come on, you. Go to number. Why are you not doing anything now? Okay. Give me just a moment. All right. Well, that's working. There we go. You're popping back up. There we go. Just a minor glitch. All right. So you said this is kind of like the same as number 1, right? Except instead of being in meters, we are now in grams. So instead of being kilometers, it's kilograms. And then you have HG. And then DAG. And then G. And then DG. And CG. And MG. So instead of all those being the M's on the end for meters, okay, so we're moving to the left, right? 1, 2, 3, and you are absolutely correct. Come on, board. So we're taking 436 milligrams And we're going to multiply that by? Come on. This board is not being nice right now. So we're moving to the left 10 times, which means it is division. Okay. It's doing something. Totally lost track of what I was doing. Oh yeah. Grams is on top. Milligrams is on bottom.
0.436.
Okay, hold on. My board's being glitchy. No, you're fine. You're doing good. Just my board's not doing so good.
Doesn't know that Friday doesn't want to work out.
I know, right? It's like it's Friday. I'm done. Ha! Ugh! All right. Grams. Let's go to a different color. That didn't work either. What is going on? All right, hold on. I'm going to exit out of this and then go back. Okay. Come on. Open up. Alright. Back to number 9. Hopefully you're not going to be as glitchy anymore. Come on. Oh, my word. Okay. All right, well, allow me to write down below. Nope. Let me do something else. Switch the pen. That seemed to help a little bit. All right, so now, okay. So we got, you said 1,000 down here. So we'll take 436 times 1 over 1,000. And what did you get again?
0.436.
There we go, 0.436 grams. Now we're cooking. Just something wrong with that one's batteries. Silly pen. There we go. And yes, it's just like the beginning one. Just like the beginning one. All right, number 10. This is the one that when we were in class and we talked, I said this is the one that kind of trips up students the most. Remember I said that in this guide that there's really kind of 3 steps that you're doing. So, step number 1, let's talk through this. So here's the problem. It says the prescribed dosage of a drug is 20 milligrams per kilogram daily. How many 100 milligram tablets should be given each day to a patient who weighs 130 pounds? And then over to the side, I give you this nice little piece of information right there that says 1 pound is about 0.45 kilograms. Do you remember what we had to do first? And what do you mean by multiply? Why? What are we doing? What are you trying to figure out? Yes, it is about the pounds. We want to figure out how much this guy is in kilograms. That's important to us. So the first thing is we need to know how much our patient weighs in kilograms. That's step number one. So we're going to take that 130 pounds and we're going to multiply it by what over what to get kilograms?
By milligrams.
By what?
20 milligrams.
No. There has to be a relationship between pounds and kilograms.
So we're going to multiply by 1 and then divide it by 0.45.
No. But you're close. The 1 doesn't go on top. The 1 is pounds. Who are you trying to get rid of? Pounds. Yeah, reverse that. Your 1 pound goes down here. Your kilograms goes on top. Remember, the label you're trying to get rid of goes in the denominator. So we're going to take 130 times 0.45. What does that give us? No worries. Got plenty of time.
$58.5.
58.5 kilograms. Perfect. All right. Now, what do we need to do with this kilograms? He's 58.5 kilograms. Do you remember what the second step was?
If I'm not wrong, we need to divide it.
What do you mean divide it? Divided by what? What do you want to convert kilograms to?
Milligrams.
All right, so yes, that's this guy right here. And this is the part that tripped me up because I wasn't thinking about it clearly. I always wanted to take that 100 milligrams. But I can't do anything with milligrams and this guy because they're not the same. That's what this 20 milligrams over kilograms is. That's a conversion for us. So we needed to, in this step, we need to figure out how many milligrams is needed. Because that's what this tells you right here. Our patient needs 20 milligrams for every kilogram they weigh. So we need to convert this. We need to take 58.5 kilograms and we need to convert it into milligrams. We need to know how many milligrams does this patient need. So what are we going to multiply by? What's our conversion? Who's going on top? Who's going on bottom? Kilograms will go on the bottom. Good. And the 20 milligrams go above. There you go. Good job. So there's what we know. So let's convert this then. What is 58.5 times 20? There you go. That's how many milligrams this person is going to need. So step 3, last step. Now that we know how many milligrams this person needs, what are we going to do now?
How many 100 milligram tablets should be given to the patient?
There we go. Now we're going to get to that question. We got to use this part. We know that every tablet is 100 milligrams, right? So what am I going to take with this 1,170 milligrams to figure out how many 100 milligrams we need? Divide it. So now we're going to figure out how many tablets So all you do is you take the 1,170 divided by 100. And what do you get? No worries. Good. Now, these would be tablets, though. If you're a pharmacist, can you give a patient 0.7 of a tablet? No. What would you actually give them then? Not 10. This patient needs to have all of this medicine. So if I give them 10, they're not getting all the medicine they need. And that could be a life or death situation for that person. Well, not cent, this isn't money, to the nearest tablet. What would the nearest tablet be? 12. This person needs 12 tablets. Now, just to talk about this real quick, to make sure that you truly understand this, if I had 13.1 as an answer, how many tablets would I give this person? No. How many tablets would I give them? It's not 13. Give me another number. No. That's 2 less. I got to have 13.1 milligrams going into this person. How many tablets do you give them? Can't give 0.1 of a tablet. How many tablets would I give them? So it's not 12. It's not 13. Those are 2 less. It's not enough. Can't give them 0.1. Yeah. You're going to give them 14 tablets. I didn't say it couldn't go above. I said they need this. Does that make sense? Yeah. They have to have 13.1 tablets, although we can't give 0.1 tablet away. That doesn't make any sense. So we have to give them 14.
So in this case, if it goes above 0.7 or 0.1, you have to give them above.
Yeah. In other words, what I'm trying to say is, if you have a decimal in this, you need to bump it up 1, no matter what the decimal is. Okay. Say it again.
Even if it's low?
Yeah, 0.1 is low, but they have to have that 0.1 in their system. Does that make sense? They have to have that 0.1. So if I didn't give them that 0.1, if this is kind of maybe, this is extreme, a life or death situation, I just killed them. Make sense? So, and as a pharmacist, I can't give out 0.1 of a tablet, so I have to bump it up. I have to give them 14. Okay? Just wanted to make sure that was clear on that one. No matter what the decimal is, round it up. All right, so the next one. So here we're talking about weight. We got milligrams, grams, and kilograms. So again, remember we talked about this in class. Milligrams, think like the weight of a pill. Kilograms, think like in pounds. And grams, well, if it's not milligrams, it's not kilograms, then it's a gram. So if we're looking at your TI-84 graphing calculator that you have there, the weight of the calculator is 50 what? Is it milligrams, grams, or kilograms? 50 grams, absolutely. Because it wouldn't be kilograms. My calculator weighing 50 pounds, that's one heavy calculator. Okay? And it wouldn't be milligrams because that's just way too light. So definitely 50 grams. All right. Number 12. So what is the most reasonable? Is it milligram, gram, or kilogram? I took 100 blank Advil. I took 100 blank Advil. Absolutely. Milligrams, always think like in pills. And pills are generally measured in like milligrams. Okay? All right. almost out of conversions and dimensional analysis. All right, last two, 13 and 14, these are all going to be about your temperature formulas. So we want to convert from Celsius to Fahrenheit. So do you remember what that formula was?
9 divided by 5. Well, if it's Celsius to Fahrenheit, 9 divided by 5, and then
Whatever the Celsius is,
75.
plus
32.
32. Yeah. So in the end, all we do is just plug that 75 in, like you just said a moment ago. And then we're going to add 32 to it. So what do we get?
$167.
167 what?
Fahrenheit.
Degrees Fahrenheit. Perfect. There you go. That's a plug and chug. Take your number, plug it in the formula, kick me out an answer. All right, and the last one from that from our chapters 9.1 through 9.3. So we want to convert Fahrenheit to Celsius. So do you remember what the formula for converting Fahrenheit to Celsius was? All right, so it's take that fraction that we had and we're going to flip it, but this time after that we need parentheses, and it would be your Fahrenheit minus 32. So all we got to do is just plug in.
So Celsius is plus and Fahrenheit is minus.
You got it.
And flip it.
Mm-hmm. The reciprocal of the fraction.
Flip the division.
Uh-huh. So in this one, round to the nearest tenth for me. 1 decimal place. Round to the nearest tenth.
$66.1.
You got it. 66
.1
degrees
degrees
Celsius. There you go. Good job. Perfect. Okay, now everything from here on out, this is all about geometry. All about geometry. Here we go. So I'm going to give you an angle measure, 27 degrees, and I want you to tell me its complement and its supplement. So what did complement mean? We're going to find the other angle that will be its complement. What did complement mean? It must add to 90. Complementary is all about adding to 90 degrees. Yes, supplement means you add to 180 degrees. So we need to know what plus 27 will equal 90. Of course, degrees. And the same thing down here. What plus 27 degrees will equal 180 degrees. So all you got to do is just find those two pieces. But the key is you got to remember what these vocabulary words meant. You got it. Complement is the 90 degrees. Supplement is the 180 degrees. So what are our angles? What are they going to be?
63. On the complement.
You got it. 63 degrees, because you just take 90 minus the 27. And what's the supplement? No worries. Okay. Because you just take 180 degrees minus the 27. Perfect. Perfect. Okay. Question 16 has two questions on it, two different pictures. And so in these, all I'm worried about, even though I gave you lots of numbers, is finding whatever angle 7 is in both pictures. So this is where you got to use those facts that we know about parallel lines, or maybe use some vertical angles, or use linear pairs to help you out. So how can I find out what the measure of angle 7 is? Oh, 65 would be the same as 4. Well, that's good, but I want 7. So how can we use, so we'll write that up there. Absolutely. Why are those two the same? Do you remember? Why are they congruent? Well, that is true. That's what congruent means. Remember that the 65 and the 4 you just gave me, those are alternate exterior angles. That's why we know they're congruent. So how does that help us get to number 7? Because your goal is number 7. Okay. So I wouldn't have jumped there, but that's fine, because that's something that you see. Everybody's going to see things differently. There is a relationship between those two. The relationship between those two is that they are a linear pair. Do you remember a linear pair, John? Two angles that form a straight line. See how these angles form that straight line? There's that common ray they share. So a linear pair, what do we know about their angle measures? They have to what? They have to pair up and add to what? The two angles have to add to
90 degrees.
not 90 degrees. They're a straight line. How many degrees is a straight line? I'll give you a hint. It's the same idea as supplementary.
180.
They have to add up to 180 degrees. Have to. Because they are supplementary. Linear pair angles are always supplementary. Okay? So what is our missing angle? How much is it? Say it again.
130.
No. You got to take 180 minus 65. 115 degrees. There we go. And there are lots of other ways to get at this angle. There are. What are they? there's multiple ways. You could look at angle 8 and say this is 65 degrees. And then these two are, again, supplementary because they're a linear pair. You could figure out what angle 5 is. Lots of different things that you can do. Ultimately, in the end, it comes down to you taking 180 minus that angle. You're going to have to do that sometime in here. And that will give you the angle that you need. All right, next question. So our goal, again, is angle 7. What is its measure going to be? No. Look for some sort of relationship between these two. Just like in the last one, there was a relationship between the angle given and that one. They were a linear pair. Is there a relationship between this angle and this angle?
Yeah, congruent.
Why are they congruent? What is their relationship? What are they?
So I have to add up to with 72 plus 9.
No. Congruent means they're the same. So our answer is that they are 72 degrees. Angle 7 is 72 degrees.
So if they're congruent, that's the answer?
Yeah, they're the same. Congruent means that you're the same thing. But why do we know that these are congruent? Do you remember why? Well, because they're the same, that's the definition of congruent, but what's the relationship? Do you remember what kind of angles these are? They're corresponding because they're in the same spot. This 72 degrees is in the lower left-hand corner. The angle 7 is in the lower left-hand corner. So they are corresponding angles. And because they're corresponding, that's why we know they're congruent.
So they're linear pairs, so I have to...
They have to form a straight line. Okay?
So let's see if I can understood better. So they're corresponding, the answers correspond. So they're linear, not linear pairs.
Slow down.
If they're congruent, they're corresponding.
And not always.
No.
There are other angle relationships. Remember, there's alternate exterior, which you gave me on the previous one. These are alternate exterior, which is why they're congruent. Remember, you have alternate interior that are congruent. You have vertical angles that are congruent. There's lots of angle relationships. And it's going to be about what you can remember about those relationships to help you out. Okay? If it's a linear pair, yes, you will want to subtract 180 off of it because linear pairs are supplementary. Okay?
What about when they're congruent?
When you're congruent, you're the same measure. You don't subtract anything. 72 and 72. Stays the same because that's what congruent means. You are the exact same shape. Okay? All right, 17. So we want you to find the missing angle. So on this guy, I'm missing angle C. So how can I figure out what angle C is? How can we figure out what angle C is?
128 plus 28.
Now multiply. Yeah. Take these two angles, add them up, and then what are you going to do? Say it again. It's not 90. Because that's not going to make any sense. This number is already bigger than 90. But there is a subtraction. I'll give you that. 180. Because remember, all angles inside a triangle must add up to 180. So yeah, add those two angles together and then take 180 minus that angle. What do you get? You got it. 24 degrees. Okay? So let's do it again. So my missing angle on this guy is L. How are we going to determine what L is? How'd you get that? I agree. How did we get 88 degrees?
72 plus 20 equals 92, and then subtracted by 180.
Okay, good job. Yeah, add that 72, add that 20, and then subtract it away from 180. Perfect. Doing great. Now, this was the other question I said in class that most of my students, what I've seen in the past, this is one of those questions where it's most missed. And again, this is because you got to think about what you see, what you know, what you remember. So in this guy, we want to find the measure of 5 different angles. We want to find the measure of angle 1. We want to find the measure of angle 2. We want to find the measure of angle 3. We want to find the measure of angle 4. We want to find the measure of angle 5. And you can do this in whatever order you want. So we just start working our way through. It's okay. So we want to get these angles all up in here. I will tell you on this one, you pretty much, you have to start with angle 1 to get anywhere else. You're going to have to find angle 1 first. Then everybody else, you can go in whatever order you want. Angle 1 is not 115. The outside angle over here is, but is there a relationship between these two? Yes, there is. If there wasn't a relationship between those two, we would be sunk in this problem. What's the relationship between angle 1 and angle 2? Or, sorry, not angle 1 and angle 2. Angle 1 and 115 degrees. They're a linear pair. What do you know linear pairs have to do? You have to, yeah, they should add up to 180. So in our case, yes, you will take the 180 minus the 115 because we got a linear pair going on. It's a linear pair. And linear pairs are supplementary. So how much is angle 1 then? $65 degrees. Good. Okay. Now, angle 2 is your next must degree because we can't figure out anybody else until we know angle 2. So with angle 2, there is a relationship between these two.
No, sorry. 115 minus 65.
No. Angle 1 we know is 65 degrees, right? Angle 2, I want to know what it's going to be. We know angle 1 is 65 degrees. So what's the relationship between 1 and 2? They're not corresponding. It is 65. Measure of angle 2 is 65 degrees. Now the question is, do you know why? Well, that's what it means to be congruent. Anytime we say congruent, that means we know they're one and the same. But why are they the same? What kind of triangle is that? You are on the right track with the triangle. What kind of triangle is that? What do those little marks mean right there? You remember? They mean congruent. Or in other words, both those sides are the same length. What kind of triangle has two congruent sides? Remember the name of it? It is isosceles. Yes, it is isosceles. This is isosceles triangle. And remember in the isosceles triangle, what did I tell you about their base angles? They're the same. They're congruent. So that's why we know angle 2. And now we can do everybody else. Now we can do everybody else. Now that we know that, yeah. And that's the real key to this problem. Once we know these guys, we can get everybody else. Because basically the key was knowing that 1 was a linear pair, and then for angle 2, you were using isosceles triangles and base angles. That's where angle 2 came from. Okay, so let's get everybody else. So you can either work with 4, 5, or 3 now. All of them are up for grabs. We got enough information to do them all. Let's do 3. So how are we going to figure out the measure of angle 3? And then what? Because they're all inside our triangle, right? This is what we just did on question 17. Add up all the angles and subtract from 180. It's your triangle sum. 50 degrees? Cool? Yep. Okay. What about 4? Or 5, whoever you want to do next. Why is it 115? I agree.
Because the same as we went at number 1, they're
What are these two?
congruent.
No.
Not congruent. Linear pairs.
Linear pairs. We love our linear pairs. All right. So that's good. So we now know that this guy right here is 115 because it was a linear pair. And then last but not least, what is the measure of angle 5?
We have to add up all the numbers and then...
Nope. Even easier. I like your subtract from 180. That'll work. But who are you going to take away from the 180? What are these two?
So we're going to add up 115 plus 4 and then...
No, not plus 4. 115 is angle 4. Oh, I get what you're saying. Yeah. Not that guy. Here, let me erase that real quick. What are these two angles?
Linear pair?
They're a linear pair. Linear pair. So we're going to take 180 minus what? And what do you get? There you go. Or another way would be these two share a relationship. What are they? They are congruent. Why? What kind of angles are they?
Vertical.
They're vertical angles. Remember, vertical angles are congruent. So again, there's lots of ways to look at this guy. You could look at it according to a linear pair, or you could have looked at that last one according to vertical angles. Okay? Again, this picture is kind of a lot like what what we did on 16, where it's based off of what you see and what relationships you can remember. All right, getting down there, almost done. Okay. So here I want to find the missing side, the side for x. And our triangles are similar, which is important to us, because without knowing that, we wouldn't be able to do anything on this. So since they're similar, that allows us to set up proportions. Because being similar triangles, remember your triangles have to be, the sides have to be proportional to each other. So remember in class I said this is all about being consistent, like going from the big triangle to the small triangle, or the small triangle to the big triangle. So John, what do you like to do? Do you like to go from the big triangle to the small triangle, the small triangle to the big triangle? Small to big. So let's keep it going that way the whole time. So we're going to do a proportion where we get something on the small compared to the same side on the big. And then we'll get another side on the small and compare it to the same side on the big. So John, give me someone on the small triangle. 8 meters. Now, who matches that on the big?
30.
Nope. The 8 meters does not match up with the 30. This side right here, who does it match on the big side? It's not the 18, it's not the 30. It's that guy right there. You see how they match up? We've got this angle right there and the right angle. This angle, the right angle. It's got to match up, sides to sides. But can I compare these two? Does that make sense? Yeah? Do you know what this big side is right here? Do you know how long that is? So that doesn't make any sense. Don't compare those two sides. You chose the one side we don't want to work with. 10 matches up with 30, yes. On the small one we got 10, on the big guy we got 30. Because they're the same sides. They're what we call corresponding sides. All right, give me another one on the small. No, we just talked about 8 meters. But I want it on the small, though. Give me the guy on the small again. X. And who matches that one on the big? 18. You got to be consistent. When we say small to big, we always go small to big. When you said 18 over X, you now flipped it on me. You did big to small. We don't want to do that. Be consistent. So how do we solve this? Do you remember, John? Yes. Good. So 10 times 18, that's 180, equal to 30 times x, which is 30x. Remember, that's called cross multiplying. And what are we going to do now? Divide. Perfect. So we're going to divide both sides by 30, and we end up with what? 6 meters. Meters. Does that make sense? It's all about matching up your corresponding sides. All right, we're going to do another one. So again, we know our triangles are similar, which is important because if they were not similar, we wouldn't be doing this. So John, do you want to go big to small or small to big?
Let's change it up.
Okay. He wants to change it up. I would have just left it the same, but that's fine. Sure. So, John, give me something on the big. Made it a little bit easier this time. I didn't give you any extra information that we didn't need. Something on the big.
Number
8. And 8 over 4. Good.
10 over x.
Perfect. So 10 over x is your other side. There you go. 8 matches the 4, and 10 matches the x. And so now we just go back to our cross multiplying. 8 times x is 8x. 40 is the 4 times the 10. And then divide. And you get what? 5 what?
5 feet.
Feet. Perfect. Perfect. All right. Number 20. So it says, find the sum of the measure of the angles of an 8-sided polygon. So this is a formula. Do you remember the formula for finding the sum of all angles? What?
So we have to sum it up by twice if I remember correctly.
It's a formula. Do you remember that formula? Okay. So the formula is n minus 2 times 180. And your n represents the number of sides. So how many sides do we have? So we're going to take 8 minus 2, and then we're going to multiply that by 180. So yes, you're correct. Take the 6 times 180, and what do we get?
So 6 times 180 is 1,080.
1,080 degrees. Degrees. Okay. Getting there, getting there. All right, so now all I'm asking you to do is find the perimeter. How do we find perimeter of a shape? How do we find perimeter of a shape?
We add them all up.
We add them all up. Who's them?
We add all the meters, all the numbers of the meters.
Okay, all the sides. Do you have all the sides? We're missing 2 of them, right? Missing 2. We're missing this guy right here. And we're missing this guy right here, right? So let's call this side 2, and we'll call the blue guy side 1. How can we find the measure for side 1, the distance? How are we going to do that? Do you know? Or side 2. I'll take either one. Which one do you want to do first? All right, side 1. So how am I going to find that missing length?
Well, we add 2 plus 7.
2 plus 7. So this 2 and that 7 down there, that's not going to help us. Well, maybe one of them could help us for side 1. Which one would help us, the 2 or the 7? The 7. Because whatever side 1 is, right? And the 7, do you know how much that should equal if we added them together? How far across should that be? So side 1 and side 7, and side 7, if we add those together, how far across should that be? Sure. Side 1 and whatever side 7 is, if I add those together, they should be 12 meters across. Does that make sense? So what is my missing length for number 1? What plus 7 gives me 12? 5. So one of my missing lengths that we need is 5 meters. Does that make sense? Because 5 plus 7 should be a length of 12. All right, John, since that kind of told you a little idea, gave you a little idea, how do you think we're going to get side 2? Okay, so it's going to be blank plus what? Plus 2. And what should that add up to? To 10 meters. Good. So side 2 plus 2 should add up to our total of 10 meters. So 8 meters is what we're missing. So now we can find our perimeter, right? Now we know everything we need. Now we can come in here and we can be like adding up all of our sides, because we now know that this is 5 and we know that this is 8. Add it all up. Take 2 plus 12 plus 10 plus 7 plus 8 plus 5. What is the perimeter? $44 meters. Good. Perfect. Perfect. Okay. So here, the problem says, find the area. What kind of shape do we have? No, you're fine. What kind of shape do we have? What is that? It's not a rhombus. Guess again. Rhombus looks like a drunk square. It's not a rectangle. Rectangles have to have parallel sides. Same thing with a rhombus. This is your trapezoid. Okay? This is your trapezoid. Remember, when we talked about a trapezoid, trapezoids have one set of parallel sides. Okay? Do you remember the area formula for the trapezoid? What is the area formula for the trapezoid? No. You're thinking perimeter if you're adding up around the outside. I want area. Do you remember the area formula for the trapezoid? Okay. So the area formula for the trapezoid is 1/2 times the height times B1 plus B2. Who is the height? It is not 5. Okay. Four other options. Say it again. Number 12 is not a height. 3 options.
Number 22nd or number 10?
Well, which one is it? 22 or 10?
22.
That's not 22. It is 10. Remember, the height is connected to the right angle symbol. The height is connected to the right angle symbol. And the other piece that gets connected to the right angle symbol are what we call the base. Okay? And for the trapezoid, that's what B1 and B2 are. The trapezoid has 2 bases. Who are the bases then? The height and the bases are connected by the right angle symbol. So who are they going to be? 12 and what? 12 is not connected to a right angle symbol. 15 is not connected to a right angle symbol. It is 5 and 22. The 12 and the 15 are junk. In your trapezoid, your 2 parallel sides are always your bases. In the trapezoid, the 2 parallel sides are always your bases. So there's what you got. All you got to do is multiply it all out. And then tell me what you get.
$135.
135 what? Yards. Squared. Because this is area. Because it's area. Perimeter labels are normal. Area labels are always squared. What are volume labels? Volume labels are cubed. Perimeter is normal. Area squared. Volume is cubed. All right, so here we got 3 questions going at once. And question A will basically flesh out what we have to do for B and C. Okay? So question A says we're basically going to find the length of the other leg. So the guy that we're missing. We want to know, who is this? How do we do that for this right triangle? How do we find that other leg for the right triangle? No. There's a formula. Everything from here on out is like formula based. It's a right triangle. Do we know any formulas for right triangles? Famous ones. Okay. Do you remember the Pythagorean theorem? No, it has nothing to do with 90 degrees. No angle measures. What's the Pythagorean theorem? Do you remember? If you had your book with you. All right. Pythagorean theorem is a squared plus b squared equals c squared. Okay. So who's your A? Let's just talk about that. All right. Plus, who's your B? Yes. And the 20 is a C. Remember that your legs are the ones that form the right angle. Those will always be your A's and B's. And you determine who you want to be A and who you want to be B. Okay? All right, so all we got to do now is do some squaring, a little subtraction, and then in the end, to get rid of something squared, we will take a square root. So what is 16 squared? Okay. What is 20 squared?
400.
Okay. So now we want to get the A by itself, so we will subtract 256 to both sides. Okay. So when we take 400 minus 256, what do we get? 144. And again, how do we get rid of something squared? We take a How do we get rid of something squared again? What are we going to take in the end? I said it a couple seconds ago.
Oh, divide it.
No, square root.
Find the square root.
Square root. So what is the square root of 144? Your square root button is above the x squared button. So you hit second x squared. Hit second x squared.
20.
Not 20. You got to put 144 in. There you go. 12 what? What are we in?
12 seconds.
Good. So there's the answer to part A, and that's crucial for everything else. You mess up part A, it's going to mess up the rest of your answers. All right. So part B says, find me the perimeter. Find me the perimeter. So we now know that this is 12 centimeters. How do we find the perimeter? How do we find perimeter? No division. How do you find perimeter? We did it earlier. No, that's Pythagorean theorem. How do you find perimeter? We did it back on number 21. You found perimeter. How did you do that?
We have to add them all.
Add them all up. Take 12 plus 16 plus 20. What do you get? Add it all up around the outsides. That will find perimeter. 12 plus 16 plus 20.
48.
48? 48 what?
48 centimeters.
Good. Okay. Now, area of a triangle. How do you find the area of a triangle? How do you find the area of a triangle? It's a formula. Do you remember what it is? 1/2 base times height. So, who is your base? The base is what?
The base is 48.
No, that's perimeter. You have to go back to your picture. Who's your base?
16.
16. Who's the height then?
12.
12. Good. Because those are the numbers that are connected to the right angle. Remember, we talked about that. All right, so all you got to do is multiply that out. Tell me what you get. 96 what?
96 centimeters.
Ugh, that's a horrible 9. Fix this. 96 centimeters squared. Its area. All right, two more. Okay. So this guy has two different parts too. We're going to find circumference. We're going to find area. Now the biggest part in this is they want you to leave the answers in terms of pi, which means they want you to leave pi alone. Your answer should have that symbol pi in it. Okay? So part A, circumference. How do we find circumference? What's the formula? What is the formula for circumference? No one. Okay. Formula for circumference is pi d or 2 pi r, depending on what you know. What does the d stand for? And the r stands for? Radius, not radio. No problem. Two different ideas. Radius for a circle, radio for listening to music. No worries. It's okay. So here's what we know. Which formula would you use? Pi d or 2 pi r? Absolutely. So if I want to keep my answer in terms of pi, all I got to do is plug in the d. What is the diameter? No, what is the diameter? 100. And to leave it in terms of pi, all I'm going to do is write down pi. Don't put in the 3.14 that you're about to spout out to me, because I want this to be exact. And then, of course, there'll be a label. 100 pi what? What's the label? That's what I want to know. No. No. The label. Feet, miles, inches, yards, meters. There it is. Yeah. You could have also used the other formula, because we do know that in order to find a radius, what do we got to do to the diameter? How many radii make a diameter? How many radii are in one diameter? No. 2. So in order to find the radius, you take the diameter divided by 2, and that will tell you the radius. So real quick, what is 100 divided by 2? So we could have used the second formula here, plugged in 2 times pi times 50. But again, we want to leave pi alone. So all you have to do is take 2 times 50, which is 100 pi meters. So 2 ways to think about it, whether you want to use the radius or whether you want to use the diameter. So that's part A. All right, part B. We want to find area. What is the area formula for a circle? What is the area formula for a circle?
Is it the area of a circle?
Yes, area of a circle.
It's 100 meters.
No, area of a circle. It's a formula. All right. Area of a circle, pi r squared. Pi r squared is our area formula for a circle. So all we have to do is plug in our radius and figure out what the answer is, which we just figured out our radius. What was it? No, that was the diameter. What was the diameter was 100. What was the radius? 50. So all we need to know, because we want to leave pi alone, is what's 50 squared.
$2,500.
2,500 pi what? Meters. Because it's area. Good. There you go. Now, on the test, it will want you to give us an approximate answer to this, which means that's where we're going to take 100 times pi and get an answer. Down here, we'll take the 2,500 times pi and get an answer. So on your test, it will actually have you do 4 answers for these. The exact answer, where you leave pi alone, and the approximate answer for both the circumference and the area. Okay? Last problem. The last problem is all about volume. All we got to do is find the volume of the shape. What kind of shape is this? Not a cube, but close. What kind of shape is this top piece right there? Just that little piece right there. Okay. It's a rectangle. This is what we call the rectangular prism. Prism. I don't know why I misspelled it. Come here. Do you remember how to find the volume of a rectangular prism? What the formula was? If you had your book with you. Well, the formula really is for a rectangular prism, big B times H, which big B means that it is the base area. Well, you already know what the base is. What is the base of this? What is the base? No, the shape.
Rectangle.
It's a rectangle. How do you find the area of a rectangle? What times what? No. You're plugging in numbers. I just want a formula. What is the area formula for a rectangle? Length times width. Length times width, or sometimes we call it base times height, but I like the length times the width for what I'm going to do right here in a second. So since the area of the base is length times width, really the only form, what they really want us to do is take length times width times the height. A normal volume formula. We know how to find volume of a rectangular prism. It's always length times width times height. Length times width times height. Because the length and the width right there, that represents the area of the base for us. So all you got to do is plug in your numbers. What's your length? That would usually be the height. 3. 3 will work. What's your width? 5. Height is 4. So all you got to do is multiply all that together. Get me an answer. 60 what?
Centimeters.
Centimeters.
Square.
Cubed. Volume. Cubed. All right. Last guy. So, What kind of shape did I give you? What is that? Cylinder. What is the volume formula for a cylinder? Do you remember?
Length times width.
That would be a rectangle. But our base on this is a what? What kind of shape is the base? A circle. What's the area formula for a circle?
Length plus width.
No, circle. We just talked about it. The formula is just like the prism. It's going to be big B times H. Again, where big B means base area. But our base is a circle. So what's the area formula for a circle? We just did it a second ago on number 24. What is the area formula for a circle?
50.
No, that's a number, a formula. What is the area formula? You're pointing to it. Pi
3.
r squared.
Pi 3r squared.
No, not 3. Pi r squared.
Pi r squared.
Pi r squared. So our volume formula, all we got to do is pi r squared h. Gosh, this pen is horrible today. Fix my writing. Pi r squared h, because that right there represents the base area. So all we have to do is plug in. And again, in this one, it says in terms of pi. So we're going to leave pi alone. Oh, my formula disappeared? The board loves to do that. So let's start plugging in. We got pi. What's your radius? 4. What's your height? 8. So all we need to do is take 4 squared times 8. 128. Slap pi after it, and our label is yards cubed. Perfect. Done.